Hello students, welcome back. We completed up to section 2. Now let's go to section 3 and study the derivatives in terms of graphs. But before that, let's have a brief review on section 1 yet again. This picture, this single static picture, summarizes entire section 1. The derivative is the instantaneous rate of change, and it is visualized by the slope of tangent line, highlighted in red. And that's the limit of the slope of secant lines, highlighted in green, and they correspond to the average rate of changes, or Newton quotient, or rise over run, those kind of things. Remember this picture. And then let's go to the graphs. Alright, here we go. We have a picture. Find all x-coordinate values at which the derivative f prime of x does not exist. The slope of tangent line does not exist. What do you mean by that? Let's see, what if I select an arbitrary point like this? Alright, here, and then what's the tangent line? Kind of like this. And what's the slope here? Slope of this line, of course, the tangent line. To the left, to the right, all the same, because it's a line. How about some other place, like this one here? The slope of this tangent line like this. Again, to the left, to the right, all the same. This point right here, well, I can find out the precise slope. Right here, the derivative is 0. The slope of tangent line is 0 because the slope is horizontal. I mean, tangent line is horizontal. Do you see that? How about some point like this? It's hard to estimate, but I can clearly see the slope is positive. About 3 or something. I don't know, it's hard to guess. How about this point here? Well, this is itself a line segment, so it's gonna be this line. So f prime of, say, 1.2, I don't care. That's negative 4/3. I can clearly see that. And does it have to be 1.2? No. How about some point like this? About 1.8? Yeah. How about here? 2.5? Or 2.8 or whatever. Anything between 0 and 3, we're going to have negative 4/3 because this itself is a line segment. All those kind of things are clear, I hope. Now, what are the values? What are the x values, excuse me, where the tangent line is invalid? I can see 3 such x values. Right here, discontinuity. Right here, and then right here. This one and that one, discontinuity, are a little bit harder. So let's go to the third one here. Why do we have undefined derivative? Derivative doesn't exist here. Let's erase and restart. To the right, the tangent line is this. See this? Tangent line is horizontal to the right. So f prime of 3 is 0 basically. I use 3 plus because all of it to the right, basically, to the right. Make sense? But how about to the left? Let me use different color. To the left, we have this line segment. And that slope is something I can find out precisely. That's negative 4/3. And these two are not the same. Left-hand side limit and right-hand side limit are different. So right here at x equal to 3, the derivative cannot exist. Make sense? The left-hand side slope and right-hand side slope are different. Left-hand side slope, that's easy because it's a line segment. Negative 4/3, rise over run, you see. 4 steps down as I move 3 steps to the right. So negative 4 steps up as I move 3 steps to the right. And to the right, well, this is horizontal, so that too is easy to see. Now this point here is a little bit harder to see. Let's look at various secant lines. Yeah, second reference point is getting closer and closer and closer. As I get closer and closer and closer, what do I get? I end up with a vertical line. Again, it's going to be the same thing. Like these. Second reference point is getting closer and closer and closer. And then eventually I'm going to get to a vertical line. Make sense? And that has no slope. How about this one here? Same thing happens to the left. Secant line, another secant line, and then many secant line, of course, getting closer and closer and closer to a vertical line, so undefined slope to the left. To the right, on the other hand, it's okay because this is a self-aligned segment. Let's summarize this. We have these three x values, x equal to -4, discontinuity, x equal to 0, again discontinuity, x equal to 3. This kind of things are called a cusp point. And then at cusp point, which is easiest to understand, left-hand side slope and right-hand side slope are different. The derivatives exist. The limit, left-hand side limit, or the left-hand side derivative, and right-hand side limit or the right-hand side derivative exists, but they're different. So overall, the limit doesn't exist. Consequently, overall, the derivative does not exist. But they exist, and they are two different values, and you can find out, you can read it from the graph. That's the easiest case. And then how about the discontinuities here? X equal to 0. To the right, we have a line segment, so all is okay. And to the left, we draw various secant lines, and you can see the secant line will approach a vertical line, so undefined. So left-hand side derivative is defined, right-hand side derivative is -4/3. They're not the same. At x equal to -4, neither left-hand side nor the right-hand side limit of this Newton quotient exist. They're all undefined. They're all going to vertical line. Find the precise value of the derivative f prime of 1. Oh, that's easy. F prime of 1. The slope, right here, x equals 1. That's line segment, -4/3. Find the precise value of the derivative f prime of -2. Right here, horizontal tangent, so slope is 0. Estimate the derivative value of f prime of 4 here. Some tangent line like this, I don't know. It's hard to tell. About 1 point something. I can clearly see it is positive. Tangent line is going upward. So if you guess -2.6 or something, you're not going to get any credit. If you answer 0, clearly not horizontal, so you're not going to get credit. Anything reasonably positive, you're going to get full credit. And 1 point something is my estimation. What is your estimation? Anyway, you can read the graph and find out. Same problem, but this time the problems are written in terms of the limit of the average rate of change or the limit of Newton quotient. Either way, you must understand they all mean the same thing. And this 2, without plus or minus, this is a full derivative. At x equal to 2, right here, what's the slope of the tangent line? That's 0. Oh, whoa, excuse me, not -2, at +2, right here. Sorry about that, at +2. It's a line segment, so -1/3. And good question, by the way. If this had been -2, yeah, this is -2, and then this is +2, then that would have been 0. Right here, horizontal tangent. Horizontal line has slope 0. That's a good problem too. And that problem appears right down here. It's Newton quotient expression, but at x equal to -2. So horizontal line. And then precise value at x equal to 3, but 3 minus. So it's left-hand side. Left-hand side slope here, -4/3. This time, Newton quotient expression at x equal to 3, but 0 plus. Plus is right-hand side. To the right, horizontal line, so that's 0. See that? Okay, we have more points, more problems. Slopes. Okay, alright, slopes. Derivative at 2, derivative at 1. No, not derivative, left-hand side. Right-hand side derivative at 3. Left-hand side derivative at 3, those kind of things. Let's see. X equal to 2, right here, okay, the derivative exists. It's a line segment. How do you find it? That's up to you. X equals 1 and 0 minus. So left-hand side slope at x equals to 1. X equals to 1 right here, and left-hand side slope. Left-hand side, so this one, or this one. Alright? What's that slope? I'll leave that to you. At x equal to 3, left-hand side slope. Left-hand side slope. Okay, similar to the previous problem. Left-hand side. And x equal to 3, right-hand side slope. Similar to the previous problem. Horizontal tangent to the right. And of course, I could have given you other kind of estimation too. Looks like to the left, slope is getting closer and closer and closer to the 0. So I could have given you this kind of problem. Ooh. Okay. X is going to -infinity and then f prime of x. I hope you can see that from this horizontal asymptotic behavior. Y coordinate is getting closer and closer and closer to +2, but the slope is getting closer and closer and closer to 0. Those kind of things. Alright, the rest of the problems are left to the students. And I'll say we are done with section 3.